Welcome to the Easy Access Project J1A. Project J1A to build a feature-rich multi-threaded Java-based email proxy server from scratch. Welcome to Chapter 4. Chapter 4 will be bridging the clients and the servers together. Okay, a proxy. Let's get into what a proxy does. Proxy is a broad term. By default, a proxy is going to imply that there are three players. Three players may actually exist all on the same machine, and they very well may exist on three separate machines. Most commonly, the three players will exist on separate machines. The middle man is the proxy server, most likely. You're going to have a client, you're going to have the middleman, and then you're going to have some sort of a destination. Now, uploading and downloading and all these terms and server and client, these are terms that the average person has heard. They really have no idea what it really means. Client server used to mean a reasonably well understood paradigm of data transmission. Typically a server would be giving more information than it would take. That's not necessarily true anymore. At this point in time in your programming career, or possibly in your understanding, your worldview of computers, I'm going to impress upon you that there is no difference really between a client and a server. The only intrinsic difference is going to be who had the port open first. So a web server is going to have port 80 most likely open first, and then a client is most likely going to connect to it secondly. So the port's going to be open, and second the client's going to connect to it. Now in the case of something like an X drive or a online file repository, if you're connecting to that web server and it's going to go through some dialogues and some web browser, and you're going to upload a file, you're going to spend a lot more time giving that file than you are taking anything. So the empirical definitions of client and server would reverse itself as you uploaded your file, because the server would be receiving, most likely, or at least most of the data. So I need you guys to really start to rewind what you've learned and realize that we're all peers on the internet, and we're all pushing data, pulling data, printing data, writing data. We've got bytes flying everywhere. The idea that there's a server out there is almost a fallacy at this point. But we do have computers that sit and wait for you to connect to them: mail servers, web servers, database servers, and we call them servers mainly because they're waiting for you, not because they're going to give you the data, not because they're going to control the information flow really, mainly because they're waiting for you first. Okay, so let's get into the proxy. Now so far at the end of chapter 3 we had created a client and we threaded it out, and now we have a multi-threaded client that will accept connections from multiple interactions, multiple socket connections. So now here's the source code from chapter 3. I want to do a little cleanup. I don't like this S. I'm sure you noticed as I was typing it. So I'm going to call this client socket. And I'm going to get rid of that S. I'm going to get rid of that S. I'm going to head over here, get rid of that S, and get rid of all instances of that S. So now the socket is no longer the S, it is now the client socket. And I'm doing that for a very good reason, because we are about to enter our journey into a world with more than one socket open by a program at the same time. And I'll do a little more cleanup back over here, and we don't need any of that. Okay, so we have our proxy controller looks pretty good right now. And this next section is going to focus almost entirely on the proxy thread. Now I'm going to head right into it, guys. So put on your helmets because we're going to do some very interesting stuff right now. We have the input stream. Everyone remembers the input stream we created in the last chapter from the client input stream. So now we're going to create an output stream. And the output stream is going to talk to the client socket's outgoing port. Okay, so we had the incoming port, which we were reading the bytes from, and now we have created a object that we're going to be able to write the bytes to, or write some bytes to, byte arrays actually. Okay, so the real question is, why would we be writing bytes back? Well, we need to write bytes back to the client because we're going to be connecting to yet another machine. So let's start our journey, and right now I'm going to call it external socket or exchange socket. I'm actually planning on hooking you into an exchange server, but we can hook into a proxy or a postfix or a Solaris server. I have a number of Solaris systems and postfix and Qmails running, so we can connect to any of them. If anybody wants to see a demo, I might do that. So we're going to create a new socket, and the socket is going to be to this IP address on port 25. So remember where we are. We are already in the run method of the proxy thread. So at this time, we can assume there's already a client, and the client has requested this communication to take place. So now we're going to attempt to talk to the third party. We've got the client as the first party, the proxy is the middleware, and the exchange server in this case is going to be the third party. Okay, and in order to talk to the exchange server, we need an output stream and an input stream. So my input stream for the exchange server is going to be my exchange socket.get input stream, and my output stream for the exchange output stream is exchange socket.get output stream. Simple enough. Good. Let's move down a bit. Try to push this down so you guys can see this all at the same time. Oh, I got a little cleanup here. Client socket. I didn't see these down here. Okay, I had to reassign those old S objects. Don't mind me, that's just some cleanup. Okay, so now we're in this while loop. And originally in our while loop, we were listening to the client and we were accepting the command of basically one line of text, or maybe something I was typing on a keyboard, and then we were detecting to see if there was a failure or we had received a enter key, and we would break out of this loop. Okay, so I'm done with that. So matter of fact, I'm just going to delete it because we're no longer going to be preconceiving any notions based on any enter key or anything of that matter. So now, keep your helmets on because we are going to add a very interesting line, and this is probably the most interesting line you're going to see. Let me clean this up. I don't care any about this array copy. I'm not worried one bit about any of this combining message links, and I'll just go into it while I'm here. There's no point in worrying about constructing arrays. There could be some sort of optimization we could get into later that we can be sure about the length of the bytes, or we could instead of doing 1 byte at a time, we could know that we were getting a better deal. Maybe 10 bytes at a time would be more efficient. There's efficiency operations that could be done right here, but for right now, I'm not interested in any of this. These bytes, these combined byte. What I had? The wrong key there. And I don't care about this combined message. I'm not really interested in any of that. Where'd my heartbeat go? Let's save the heartbeat. That was a bunch of undo commands I just did. Here. Okay. So what I'm going to do is, instead of all that, combining stuff and games, I'm going to add this line. Now, this line states that when we receive this next byte of information, we will push that byte into a byte object, and then we will set our heartbeat, obviously, and I'll take that same byte and I will push it out to the socket that's been created to the Exchange server. Okay, so data came in, I intercepted the data, I created a tiny little container, a byte object array, and now I'm going to push the byte object array out to the third-party client. Okay, now that's only one part of the conversation. So we're dealing with the part where the client talks to me and I talk to the Exchange server. That's only half. So I'm going to copy that, and now I'm going to, while I'm in this little loop that I've created, I'm going to also check and see if there's anything coming from the Exchange server input stream. Okay, sorry about that confusion. So we're going to watch the Exchange server input stream, and if it has any data, I'm going to take my little container, my little bucket called the received, and I'm going to stick what's available from the Exchange server input stream into my bucket. Okay. And the actual, oops, sorry guys, bear with me. My copy and paster isn't working. Okay, so here I'm creating the little bucket. I'm actually defining the length of the bucket here at this point. I guess that should be more specific. I could probably do this all in one line. If you ever wanted to do this in one line, it would be something like, I don't know if this would pass the compiler, but you could stick it in there like that. See how that would work? But I'll break this apart to keep it basically simple. Okay. So we're going to create the byte array length, stick the byte array from the input stream into the bucket that it goes into. Then I'll reset my heartbeat, because now I have definitely received at least some information. Now I'm going to take that bucket of information and I'm going to write that out back to the client. Okay, so we received information from the client, and now we're receiving information from the Exchange server and writing it back to the client. Okay, and I don't care about any of this. I'll do the Exchange. The client ID has been disconnected. That's great. I'm going to add the Exchange socket close, and I don't know if I went over this stuff, but I like to set these objects equal to null on the way out. I don't know if you explicitly have to, but I've seen memory management problems all over the place when you get into these loops and you start defining objects. Some of those unwritten rules. Okay, I'll do a little cleanup. I don't need this object anymore. And we're looking good. And I don't know, EW, this is, and if I have all my curly brackets, the whole world looks good. Start the engine. JVM bind is already in use. Hold on, let me fix that. Let's try that again. Okay, we're serving on port 25. We're gonna have a lot of fun here, kids. We're gonna telnet into my IP address on port 25. And look at that. We're now connected to an Exchange server. Hello, hello. Mail from me at me.com. Receipt to blah blah blah. Not gonna like that. RCPT to NISTRATOR at SGA.com. Data. And I just got an email. How about that? So we're looking good. For those of you who needed that narrated a little better, connected, I proxied the connection through to the Exchange server, and I happen to know SMTP commands like the back of my hand. So for any of you who need these decoded, mail from is who your mail's from, and your receipt to is who your email is going to. And the data command gets you to the point where you can set your parameters in your subject and the body and the contents of your email. So, but you don't need to really know any of that. I just thought I would narrate it. So this is great. And the system is reporting in that the client is connected and is now disconnected. And we are good. So let's get to the next point that I want to go over is the text logging. Now, we really don't know. At this point in time, we're just a proxy. Now, we're not a filter yet. We're still proxying. So this is a very simplistic way of getting data through a third-party server. So this computer could be in any location in the world, and it could use this handshake bucket technique to move data byte at a time or a byte array at a time to the client. This would be a kind of a novel approach to kind of hiding your IP address if you wanted to. So if you could, let's say you had a Telnet account or a shell account somewhere, you could, in theory, send an email, use a program like this, and make it look like it's coming from another location. I don't advise it, but it is done for things like that. Now, I don't want to blow this out of proportion. This is about the same functionality as a map socket in Wingate, if anyone uses Deerfield Wingate. And we haven't cured any forms of cancer here yet, kids. This is as simple as it gets. But what I do want to do for you guys is show you how to capture the data as it comes through. And this would give us some idea of how we're going to regulate what's going on. So I'm going to create a new print writer, and here's the file location. So I'm creating a new writer object, print writer object, and I'm directing it to my c:/temp client_id.log. Okay, so don't lose your cool yet. This is simple. So I'm creating a new file, and the file will be named incrementally for every connection that comes along. And the ID parameter that we created earlier will automatically take care of that for us. Then, as a first line, I'm going to write the identification of the thread that's writing to the file. Okay, that's actually as simple as I could make it for you. So now the actual writing would happen down here as we are looping through, getting the information from each socket and delivering it back and forth And since I used the same received as my little bucket, I could call this bucket. Should I change this to bucket? Let's do it. Let's change this to bucket, because that would be the neatest. Bucket. Charlie Bucket. Remember Willy Wonka? So the bucket now has, I could do a find and replace, I guess. Now the bucket is properly named. Let's do that. That'd be fun. Okay. So now the bucket is filled, and then the bucket is emptied, and we will, as the bucket is filling and empty, we will just borrow the contents of the bucket every time the bucket is filled, and we will print it out to my print writer. And it's this exact same command down here, since we used the same bucket object. Okay. And then we could do a flush here, but I'd rather do my flushes down below. For those of you who don't get into a lot of file I/O, if you call a print writer object and you print to it, it has a tendency of not actually writing anything until you flush the data. This is some sort of an optimization thing that's been done, and it's not a bad idea. So I got to call writer.flush, and I will call writer.close down here. Sorry guys. I was going to type this all out, and it's to try to keep you guys the speed of these lessons down below half an hour. I'm pasting. So that should be good. Okay, well, let's start up the engines, and we will see what we will see. I'll get you guys up and running. Compiled, and we're good. I'll bring up Telnet prompt, and the proof will be here. We're going to Telnet to myself at port 25, and we are connected to an Exchange server. Hello. Mail from a@a.com. Receipt to administrator at sgatalent.com. The data goes here. Email body. And if anybody knows anything about terminating emails, a period on a line by itself terminates the email. Now, at this point in time, we created an email. I just actually received that email. I don't know if you guys heard that. And there is a 20-second timeout on this thread. I could change that. And what you could easily do in the future is detect the state of the socket and close the socket earlier. And you could do that by watching the data. And if you know the termination sequences, you can detect those. Okay, so hopefully we got something out of that. And let me go grab it. Sure enough, here it is. I'll drag it over so you guys can see it. And we have a log file here. Client 1 is connected. I should have done a write line, so the carriage return there clears that up. Server, client, server, client. Server, client says, server says, client says. On and on. Just what we saw. Okay, so now we have a log file of the socketed communication between the client and the supposed server, the Exchange server in this case. And we were able to do that by sampling the byte flow as it went through and redirecting to a print writer. This is as simple as I can possibly make a double-socketed communication proxy server for the educational purposes. So we went through the players, we went through creating the outgoing socket and the objects involved. We went to text logging and identifying each party's data. We could do something more involved about labeling each party's data. Wouldn't be too hard. We tested, and let's just take a second, take a look at the memory. Socket, we got 2 sockets equaling to null. We could do this writer equal to null, if you like. Writer equals null. If you're one of these guys who wants to make sure all your objects are flat lined out, and your bucket equal to null as well on the way out, to make sure that all the objects have been released. And that doesn't actually release them, that just sets them to the null state, and probably makes it a big target for the garbage collection this way. The real problems you get into with socketed objects is socketed objects aren't properly closed. And if they're not closed, the garbage collector can't clean them up. Okay, well, I appreciate you guys listening to me through Chapter 4, where we bridge client and server together and achieve text logging for the data of each party. Make sure you click to subscribe. Soon we'll be going into Chapter 5, where I plan to start to manipulate the data stream. So for us to properly look at filtering and manipulating information, we need to start to analyze the byte flow as it goes through. And if we can analyze the byte flow, we can do pattern matching, we can look for spam, we can look for virtually anything. One of my most important reasons for writing these programs was a access filter. I run a lot of email servers, and one of the common spam attacks is kind of a harvester attack. So in a harvester attack, the client tries to harvest all the names out of the email system it can. And if it doesn't know the names, believe it or not, these guys will randomly generate names. And they're just trying to see if the email will be rejected. So you'll see one of my ideas, or one of my theories on how to handle harvester attacks, and how to make sure that only emails that belong in my system make it to my system. You'll see that there's a lot of systems, a lot of email attacks where they'll send an email to you knowing your email address, and then they'll CC a name in your organization that doesn't exist, and then they'll get the email server to acknowledge that the primary recipient of the email is good, and by that time it has to decide what do I do when somebody CCs an email address that doesn't exist, but the primary, the receipt to does exist. So we look into some of those theories, and we look into some of those problems, and it's going to be a lot of theory work in Chapter 5. Also, there's going to be IP address blocking and any number of fun things. So I appreciate you guys suffering through this with me, and I hope to see you soon.